Welcome to second grade, Unit 4, Extending Place Value Understanding to 1000. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 4. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 4. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of this video, we will look to see how the AKS and IOAs in this unit are paced in detail. This unit has 3 AKS, AKS 1, 2, and 4. Under the AKS, you will find the Indicators of Achievement, or IOAs, that we are teaching at this time. For AKS 1, we will focus on IOAs 1A, 1B, 1D, and 1E. AKS 1C which is a counting standard, will be clustered with AKS 2 through IOA 2B. AKS 2, IOAs 2B and 2C, AKS 4, IOA 4B. You will also see that we have provided you with a state coding at the end of each IOA, so that if you are looking up resources on the Georgia DOE website, you are able to find the IOA that is related to the GCPS IOA. IOAs without the state coding at the end are specific to Gwinnett, such as IOA 1A. In Unit 1, students built their knowledge of patterns in the place value system. Students used place value understanding to explain and represent the values of 3-digit numbers in a variety of ways using hundreds, tens, and ones, and to compare numbers to 1000. When continuing with AKS 1, IOAs 1A, 1B, and 1E this quarter, students will continue this work with a greater emphasis on the higher 3-digit numbers. In quarter 1, students only compared 3-digit numbers when learning AKS 1, IOA 1D. In this unit, students will compare and order 3-digit numbers within 1000, with an emphasis on place value and equality. Students will compare using comparison symbols to record the results of the comparisons. Spiraling for this AKS will support students as they move towards mastery. In this quarter, students will pick up where they left off with AKS 2. Through IOA 2C, students will solve problems involving the addition and subtraction of 2-digit numbers using part-whole strategies. Add up to 4 2-digit numbers using strategies based on place value and properties of operation. In the first 3 units, we limited students to adding up to 3 2-digit numbers. However, we will meet the full expectation of this IOA by adding up to 4 2-digit numbers in Unit 4. Through AKS 2, IOA 2B, students will continue utilizing mental math strategies of finding 10 or more, 100 or more, 10 or less, 100 or less than a given 3-digit number, including multiples of 10s and multiples of 100. In Unit 4, you will notice that the numbers in our suggested lessons and tasks may be larger than they were in quarter 1. Also notice that we have clustered AKS 1, IOA 1C with IOA 2B and IOA 1C. In our sample resources, IOA 1C is taught exclusively through activating strategies. In this IOA, students will count forward and backwards by 1 from any number within 1,000. They will count forward by 5 from multiples of 5 within 1,000, count forward and backwards by tens and 100ths from any number within 1,000. And finally, they will count forward by 25s from 0. We will also revisit AKS 4 IOA 4B to give students the opportunity to continue exploring patterns involving addition and subtraction within 1,000 using models and representations. Through IOA 4B, students will continue to identify, describe, extend, and create numerical patterns resulting from repeating an operation, such as addition and subtraction, involving intervals of 1, 2, 5, 10s, and 25s. You will notice in the suggested lessons and resources that we will include patterns involving the same intervals, but the numbers in our suggested lessons and resources may contain larger quantities than they did in quarter 1. Hello, second grade teachers. Welcome to Chapter 2, Unit 4. Our pacing guide is closely aligned with the state pacing. With the first year of new standards, we want to ensure we are following the expectations from the state. The pacing guide is an example intended to model how instruction of the AKS IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. Now, let's take a look at our suggested pacing for Unit 4. In this box, which names the unit, extending place value understanding to 1,000, you will see the suggested pacing. For Unit 4, we suggest 5 weeks. The big idea in this unit is numerical reasoning. This unit has been divided into 4 parts: place value, addition and subtraction through problem solving, counting and fluency, and a revisit to patterns. The pacing guide is set up with a list of AKS and IOAs, which have been strategically clustered together. This is followed by our suggested pacing. In the left column, you will see the learning progressions for the AKS and IOAs. This includes the concrete representational abstract progression and the progression between specific learning targets within the IOAs. You will also see suggested manipulatives in this column. The right column provides resources to guide instruction, such as GCPS traditional lessons, task-based lessons, and resources from the Georgia DOE. Unit 4 begins with AKS 1 and IOAs 1A, 1B, and 1E under the umbrella of place value within 1,000. This cluster of IOAs is paced for 5 days. You will notice that the first day starts as a concrete day using base 10 blocks because it helps students build capacity for conceptual understanding of place value and related standards as they move through the concrete representational abstract progression, or CRA. Although students explored these standards in Unit 1, we want to make sure to expose them to situations involving greater numbers in Quarter 4. As we continue through the CRA progression, we begin to connect base 10 manipulatives to their correlation to base 10 drawings. I am also excited to add that within these 5 days, there are several opportunities for students to engage in task-based lessons provided by the Georgia Department of Education. Task-based lessons are a great way to invite students into the learning because of the increased chances to collaborate and explore on an inquiry level. On the fifth day of these standards, students will be expected to work on the abstract level in order to analyze numbers and reason about place value without the use of visual models. Immediately following place value, students will apply their knowledge of hundreds, tens, and ones while they compare and order numbers up to 1,000 through IOA 1D. In Unit 1, students compared numbers but did not order them. In Unit 4, students will compare as well as order numbers. Because of their previous experience with this standard, the first of the 4 days paced begins with comparing 3-digit numbers on a representational abstract level. Students will transition from using number lines to comparing 3-digit numbers using appropriate symbols to reason in order to compare 3-digit numbers flexibly with appropriate symbols on an abstract level. Next, notice that we have provided a concrete lesson to begin the combination of comparing and ordering numbers. Like before, we will connect base 10 manipulatives to base 10 drawings and eventually progress to the abstract level on which students will interpret and distinguish between place values to compare and order numbers to 1,000 without visual support. Note that students will use less than, greater than, and equal to symbols to compare but not to order. As we revisit AKS 2, IOA 2C, students will begin on the concrete level as they add 4 two-digit numbers. Previously, we limited them to only adding 3 two-digit numbers, but at this point in the year, they will add 4 two-digit numbers within 1,000. They will spend 5 days progressing from using base 10 blocks to number lines to reasoning abstractly in order to combine 4 two-digit numbers within 1,000. Along with GCPS suggested lessons, there is a task-based lesson provided on day 5 of IOA 2C. You will notice for the next 4 days of the pacing, students will build foundation and fluency through the clustering of AKS 1, IOA 1C, and AKS 2, IOA 2B. IOA 1C will be taught exclusively through the activating strategies. This IOA allows students more experience with building a foundation for multiplication in the next grade band. They will count forward and backwards by ones, tens, and hundreds from any number within 1,000. They will skip count forward by fives from multiples of 5 and by 25s from 0. The main focus of this part of the pacing is on building fluency by adding and subtracting multiples of 10 and 100 to given 3-digit numbers. This standard also allows students to notice the patterns created when adding and subtracting the multiples of 10 and 100. Like earlier in the quarter, students will correlate base 10 blocks to a representational strategy. In the suggested lessons, notice a connection between base 10 blocks and thousands charts. Refer to the Analyzing the Standards document for AKS 2, IOA 2B to see an example of how to use a thousands chart. As stated in the first quarter videos, AKS 4 is a new AKS for second grade. In this unit, Students will identify, describe, extend, and create numerical patterns via AKS 4 IOA 4B. Although students experience this IOA in Unit 2, we are revisiting it in Unit 4. In this unit, we will finish out the semester, giving students the opportunity to not only identify, describe, and extend patterns, but to also engage in creating numerical patterns by repeating an operation, such as addition or subtraction, involving intervals of ones, twos, fives, tens, and 25s. Students will use base 10 blocks and thousands charts as they explore numerical patterns through the concrete representational abstract progression. Hello, second grade teachers. Welcome to Chapter 3, Unit 4, Instructional Strategies. In this video, we will explore math instructional strategies for your second graders. Let's look at AKS 2 IOA 2B. This IOA requires students to develop numerical fluency by finding 10 more or less, 100 more or less than a given three-digit number. Notice that students will use base 10 blocks, hundreds charts, number lines, and thousands charts to support their learning. You'll notice that the thousands charts have been added to the area for considerations and suggested manipulatives. Working with a thousands chart will be new for most of your students, so be sure to be explicit about what it is and how to use it. Make sure they understand that a thousands chart concept is an extension of what they already know about hundreds charts. They should remember that hundreds charts are composed of rows and columns. These rows and columns consist of 10 sets of 10, whether you're referring to numbers between 1 and 100, or 301 and 400, and so on. Also, remind students that in first grade, they learned that the square directly above a given number on a hundreds chart is 10 less than that number, and the square directly below a given number is 10 more than that number. When working with larger numbers, the same concept applies. Also, you can refer to the AKS 2 IOA 2B to see an example of using a thousands chart to add 10 more or 10 less than a given three-digit number. Today, I would like to model an example of adding and subtracting 10 or 100 more or less from a given three-digit number. Remember that one of the considerations of this standard is that students can add or subtract multiples of 10 or 100. It's actually in our considerations column. So multiples of 10 or 100, not just exactly 10 or exactly 100.
Now let's look at a practice problem on the representational level. Byron saved $378 to purchase a fancy new purse for his wife. If he spent $288 on it, how much money did he have left? Well, some students may get really excited about this problem, but feel free to change the purse in the example to something your students might relate to better. Well, first, I'm going to use a part whole map to make sense of this problem. I know that the total amount of money Byron has or had was $378. So I will place that value in the largest part of my part whole map. That's going to represent my whole. Next, I will place $288 in one of my parts to represent the amount of money Byron spent. Okay, so this is the amount that Byron spent. This is the whole. The other part is empty because I do not know yet how much that part is. So I'll place a question mark to represent the unknown. And for students, I might even label that as the whole This is the amount that was spent. And this is the amount that is unknown. So now, I know that joining parts will equal the whole. So I know if I add those together, that's going to equal the whole. So I need to determine the value of the missing part of the unknown amount. Now I understand the problem a little better. I understand that the total amount of money Byron saved was $378 and that one of the parts is $288. So I need to figure out the difference between these two numbers, between 378 and 288. I can write an equation to represent this situation. So one way that I can think about this scenario is by using think addition to help me find the difference between 288 and 378. So I'm going to write my equation as 288 plus the unknown, my question mark, is going to equal 378. So I will use my question mark again to represent what the unknown is. That's the amount I don't know. And I just know that I need to figure out the difference between these two numbers. Be sure to explicitly model your thinking for students because when working with large numbers, they need to merge what they already know with this new information. Note that we are not adding or subtracting three-digit numbers. We're finding 100 more or multiples of 100 more or 10 more or less or multiples of 10 more or less, okay? So multiples of 100, multiples of 10 are also considerations of this standard. The first way I would like to model finding the value of my unknown is going to be using a thousands chart. You can certainly create a class thousands chart comprised of 10 hundreds charts taped together to add to your math resource wall, but today we will only use the parts of the thousands chart that we need.
So, because we know that 378 appears between 301 and 400, I will highlight it on this portion of the thousands chart. So I'm just going to go straight to 378. And I'm going to highlight that number. Okay. I will also highlight 288, where it appears on that portion of my thousands chart between 201 and 300. My goal is to determine how many squares there are between 288 and 378 on my chart. That will tell me how much money Byron had left after he bought the fancy new purse for his wife. So I'm going to start at 288, remembering that the square below 288 is 10 more. So 10 more than 288 is 298. So remembering again, because I went down that one row from 288 to 298, I added 10 more. So we want to make sure we're explicit with students about that. Now, I can see that 10 more than 298 is going to take me across the century mark here at 300. So it's going to take me to the next part of my chart. 10 more than 298 is 308. I will continue finding 10 more until I reach 378. So I know that this was 10 more, 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 and then I finally reach my 378. Again, you want to be explicit with students to make sure they understand that each time we go down, we're adding on 10 more, 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 and 10 more. Now that I am at 378, I can apply what I know about skip counting to skip count the number of squares by 10. So I know that this was one jump, so that's 10, 20, 30, 40, 50, 60, 70, 80, 90. There are 9 rows of 10, which is 90. So Byron has $90 left. Students have been working with fluency at this point of the school year, so they have been practicing that skip counting. Here's a way to have them use it. So I go back to my equation to fill in what I know. I now know that $288 plus $90 equals $378. So in my example, I chose to use think addition. I added up to subtract or find the difference between two numbers. I could have easily used subtraction to find the difference as well. I could have written the equation as $378 minus the unknown equals $288. And in this case, I would have started at 378 on my thousands chart and then model how to take away each 10 until I went to the previous number, and I would be going backwards, 10 less, 10 less, 10 less, 10 less. So I could have modeled it that way as well. Remember that the goal for this standard is for students to gain fluency in adding and subtracting 10 and 100, including multiples of 10 and 100 from a given 3-digit number. So we want them to be able to think about situations in more than one way. Another way to solve this problem on the representational level is to use an open number line to show the difference between 378 and 288. For example, using the think addition example, 288 plus my unknown equals 378. I would begin using an open number line, which means that I don't have any numbers on it. I would begin by writing 288 on the left end of my open number line. So even though it seems obvious to us, it may not always be obvious to students why we put the numbers where we have. So it's important to let students understand that, or help them to remember that numbers increase as we move right on the number line, and they will decrease as you move left on the number line. So it's important for them to know why you put that amount on the left side of your number line. Okay, so if I jump from, so again, I'm trying to go between 288 and I'm trying to arrive at 378. So a way that I could do that is to jump from 298 to 10 more. And we know that this digit in the tens place will be increasing. 10 more would be 298. So now that I know I've dropped 10, I'm going to keep going because I'm trying to get to 378. I jump 10 more. Again, I know that I'm crossing the century. I know that 10 more is going to put me at 308. And it's certainly fine for students to refer back to their thousands chart if they get mixed up as to what happens after they pass 298. Okay, they'll be able to see it's 308. Okay, and again, we're going to do 10 more. 10 more than 308, we know is 318. We've added that next 10. We add another 10. 328. We're not there yet. 338 is 10 more. 10 more than 338 is 348. 10 more, 358. And I am totally not perfect when I'm doing these jumps. I start out big and I go, uh-oh, I didn't do it. My writing small enough. Sorry about that. But it's real teaching, right? 378. Okay, so we've reached 378. So again, I can model from my students, and my students should be able to skip count how many tens there are and what that value is. So we jumped 10, 20, 30, 40, 50, 60, 70, 80, 90. So again, the value of my question mark here is $90. To fill in my equation, I would say $288 plus $90 equals $378. So how much money did Byron have left? Byron had $90 left. Again, in this case, I decided to start at 288 and add up to find the difference. We certainly could have done it the other way around, started at 378 and jumped backwards to show the difference in that way. Both ways are going to yield the same result. So one reason why using an open number line is a beneficial strategy is that it allows students to chunk numbers as they see fit. For this sample problem, it was appropriate to add and subtract by multiples of 10 like we did. However, if students were to jump 5 or 20, or you may even have a student who jumps 100 and then jumps back 10, that's okay. We encourage students to be able to find reasoning through these situations and make sense of the mathematics for themselves. The second standard I would like to discuss is AKS 4 IOA 4B. As stated earlier, through this new standard, students will identify, describe, extend, and create numerical patterns resulting from repeating an operation, such as addition and subtraction. Last quarter in Unit 2, students did not do the last part of the IOA 4B. They did not create a new pattern. So when you look at it, that's the part that they didn't do, creating the new pattern. In Unit 4, students will do all parts of this IOA 4B. We're going to be focusing on numerical patterns only. So let's recap. Students will need to use the information in the given scenarios to identify the pattern. After identifying the pattern, they will be able to describe to you what the pattern is. Once they can describe the pattern, they should be able to extend it by expressing which numbers would come next. And lastly, they should be able to recreate the pattern with a different set of numbers and be prepared to discuss similarities and differences. So here's an example from the Unit 4 suggested pacing. Describe the following pattern of base 10 blocks. Build models to represent the next two terms. Create another pattern of numbers using the same rule. What do you notice about the two patterns? How do they change? Well, first I notice that there are two things to look at in this scenario. I have to look at a paragraph and a picture. First, I want to reread the paragraph to make sure that I understand what I need to do. So it tells me to describe the following pattern of base 10 blocks. So I'm going to be using the picture to help me understand what I need to do. I have to reference the picture of base 10 blocks, okay? It tells me that I'm going to need to build models to represent the next two terms, and then I need to create another pattern using the same rule. So I'm going to be describing, building, creating, and then I have a question here. What do I notice about the two patterns. So I need to also be able to notice. And then I'm also asked, how do they change? So what changes there between the patterns? So basically, the paragraph tells me what to do in reference to the picture of base 10 blocks. So I really want to think about what I noticed about these base 10 representations. So in the first part, or in the first term, I notice that I see 3 flats. I know that a flat can represent 100. So 3 flats will represent 300. So I'm just going to write 300 to my paper. In the second term, labeled second term, I see that there are also 3 flats. So there are 3 flats again. But I also notice that there are 5 units. So the flat has a value of 100, and I know that the units have a value of 1 because it takes 100 units to equal a flat. Therefore, the second term has a value of 305. Lastly, I see that the third given term has 3 flats and 1 rod. I know that 10 units is equal to 1 rod. So the value of term 3 is 310. The next thing I want to do is notice how the base 10 model is changing and what aspects remain the same for each term. So I notice that in each term, there are 3 flats, or 300. I also want to figure out how they are different. Well, in term 1, there are 0 units sitting off to the side. I only have the flats. In term 2, I see that there are 5 units in addition to the 3 flats. In the third term, I notice again, we have a rod, but no loose units. I think I'm ready to identify the pattern. So the pattern here was 300, 305, 310. I noticed that in the ones place, the digits are alternating between 0 and 5. I want to describe the pattern by saying that a value of 5 is added on for each subsequent term. So now I've identified and described the pattern. Next, I will use that information to extend the pattern. The problem asks me to build the next 2 terms using base 10 blocks. The rule for this pattern is to add 5 to the next term. So I will build a model to represent 5 more than 310 for the 4th term. Okay, so I'm going to use 3 flats, one rod, and 5 units to represent my 4th term. Okay, so I know that is going to be equal to 310 plus 5. So the third term had 310. I'm adding 5 more because each one of the terms added on 5. So my 4th term is going to be 315. Okay. Now I was supposed to do 2 terms. So here's the next term. 3. I have my 3 flats. That still hasn't changed. And then I'm going to be adding on 5 more. So I am at 315. I'm going to add 5 more. So I have my 3 flats. I'm going to be adding 5 more. I know that I already had a rod, and I know that 5 units plus 5 more units is equal to another rod. So 315 plus 5 is 320. So for my fifth term, I have 320. So the next part of what I need to do for this IOA, we didn't do in quarter one, which is create a new pattern. The problem asked me to extend the new pattern. I'm going to extend it for 2 terms. In this given example, the numerical pattern added 5. I will extend that pattern using a different start number. I will choose 231 as my start number. I'm going to build it using 2 flats, 3 rods, and 1 unit. The problem asked me to extend it. So the second term is going to be 231. Still thinking about my adding 5, I'm going to add on 5, right? So that means that my next term is going to be 2 flats again. I'm going to have my 3 rods like I did before. But this time I'm adding on my 5 more. Oh, I'm sorry, I didn't put my unit. So I'm going to add 5 more to that. 1, 2, 3, 4, 5. I now have 6 units. So my second term is going to have 236. Okay. And then I said I would extend it 2 terms, so I'll do it again. I am going to put my 2 flats again. And then I'm going to get my 3 rods. I was already at 6 units. That's going to give me 1, 2, 3, 4, 5, 6. Now, when I add my 5, 7, 8, 9, 10, 11, I notice that I'm going to have 10 units here. So I know I'm going to have, and I'm going to have 1 left. So that's 231, 32, 33, 34, 35, 36, 37, 38, 39, 41. So I can either leave it like that, which would be 241. But if students notice, you can easily swap out your units for a nice rod. Okay, so again, my second term was 236 because I extended my adding 5 and came up with 236 after my 231. And then I created 241. If I continued this pattern, I would have 231, 236, 241, 246, and so on. The ones place keeps alternating between a 1 and a 6, a 1 and a 6. So to answer the last part of the question, let's think about both patterns. And when I say the last part of the question, I'm going to flip it back over to our original question. How do they change? So we've already described our pattern. We've already identified and created another pattern. We've already noticed the patterns. Okay, so in the first example, our pattern alternated between 0 and 5 in the ones place. In the one that we created, it alternated between 1 and 6 in the ones place. So now we're being asked to think about both patterns. Okay, so I noticed again, the ones place is what was different. The pattern I created using the rule follows a different pattern in the ones place when I do the 1 to the 6, the 1 to the 6. To sum up what I noticed in this problem, both sets of patterns follow the rule of adding 5, but because I started with a different amount of base 10 blocks in the first example, and the second one that I created had a different amount of base 10 blocks, the pattern of numbers in the ones place were different. So to summarize, this is a fun standard for students to learn because there is a great opportunity for hands-on learning and collaboration as they discover and work with patterns. Be sure to model your thinking with students. Remember, this standard is new for them, so modeling your thinking will help them understand how to think through different experiences with patterns.
So, which strategy? In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. From the Georgia DOE's Comprehensive Grade Level Overview. To ensure completion credit in PD&E, please be sure to complete the following Google form. Please scan the QR code in order to get the Google form. Thanks for watching.